Hi everyone, welcome to my YouTube channel. Myself, I'm Lokita GS. I'm studying 3rd SEM Engineering in Sri Venkateshwara College of Engineering. I'm from the Department of Artificial Intelligence. Today's subject, which I'm going to speak or explain about DSA, the subject code is BCS 304. Today's topic, which I'm going to speak, is pair matrix multiplication. It is a topic which is related to DSA. Introduction. Pair matrix multiplication is a specialized technique used to efficiently multiply two pair matrices. Pair matrices consist mostly zero values and have a distinct structure that allows for optimization. The goal of pair matrix multiplication is to reduce computation complexity and memory usage compared to traditional matrix multiplication. The given picture or a slide shows the representation of matrix multiplication normally and how the resultant matrix is done. Pair matrix. First of all, what is pair matrices? It is a matrix which has more number of zero elements and a very few non-zero elements. It can be in one-dimensional, two-dimensional and etc. Example 0, 10, 0, 0, 12, 0. It is an 1D which represent first row, first column of the elements where the non-zero elements 10 and 12 are mainly represented in the matrix representation. The abstract data type, an ADT, which means abstract data type pair matrix, is the one that shows the various operators that can be performed on pair matrices. It consists of various objects and functions as shown below. An ADT array is objects, a set of triplets where row, column, value is represented. A value is where it is indicated at which row or which column the value is present. Function parameter used. B belongs to array, max row and max column belongs to the index and n belongs to the integer. Here the value of the non-zero element is indicated by representing rows and columns where it belongs. Pair matrix create max row max column creates a two-dimensional array with rows and columns. In pair matrix representation, the rows and columns are very necessary. Advantages of pair matrix multiplication. Pair matrix multiplication reduces the number of operators required, leading to faster computation. It minimizes memory usage by storing non-zero elements and their indices. Pair matrix often arise in real-world applications such as network analysis, image processing, and scientific stimulation. It is an example of how the matrix is represented in pair matrix in DSA and where the non-zero elements are indicated with the values which is present at number of rows and columns. Disadvantages of pair matrix. A pair matrix consists many zeros. If we are manipulating only non-zero values, hence we are wasting the memory space by storing unnecessary zero values. Here only the non-zero elements are stored. If we are storing zero values, the unnecessary space of storage is simply waste. This can be overcome by storing non-zero values. If we store only non-zero values and others are obviously indicated that they are zero, so it is very essential and it is very useful for memory space and it can't be stored unnecessarily zero values. Spare matrix multiplication algorithm steps. Step 1. Identify non-zero elements in the first matrix. Step 2. For each non-zero element, locate corresponding non-zero element in the second matrix. Step 3. Perform multiplication and additional operations for each pair of non-zero elements. Existing spare matrix multiplication algorithm. There are various algorithms for spare matrix multiplication, including the CSR algorithm and the COO algorithm. The CSR indicates compressed spare matrix and COO indicates coordinates algorithm. This algorithm differ in their data structures and strategies for identifying non-zero elements. Each algorithm has its advantages and trades-off depending on characteristics of matrices. Applications of spare matrix multiplication. A spare matrix multiplication finds application in various fields such as network analysis, recommendation systems, and scientific stimulations. It enables efficient analysis of large-scale networks such as social networks and transportation networks. A spare matrix multiplication is also used in image processing tasks like image compression and desonization. Thank you for Thank you for listening to the whole video, and please do like, share the video as it contains